Okay, this lecture will be on 6.2, applications of normal distributions. The key concept we want to introduce is that when working with normal distributions that are not standard, meaning the mean is not 0 and the standard deviation is not 1, that would be not standard. We can standardize it or transform it into a standard normal distribution and then get the information we need from the standard normal distribution, then transform that back to the particular distribution we're working with. To make that transformation, we'll use this conversion formula, which will take the scores from the distribution we're working with and the mean and the standard deviation of the distribution we're working with, translate those scores over to a z-score, which is z-score corresponds to a score for a standard normal distribution with mean of 0 and standard deviation 1. Illustrated here, you have your non-standard normal distribution, so mu does not equal 0 and standard deviation does not equal 1. And it will take a score from your non-standard normal distribution and shift it over to a standard normal distribution. The reason this works also is because any normal distribution has to have roughly the same type of shape, and the entire area under both curves is 1. So the procedure for finding areas with non-standard normal distribution, it helps to sketch a normal curve and then shade in the region for the desired probability that you're asked to find. And then for each value of x that you need, use your transformation formula. And then you can use technology to find the associated areas for those regions. So we'll start with this example. Heights of men are normally distributed with a mean of 68.6 inches and a standard deviation of 2.8. Find the percentage of men who are taller than a showerhead at 72 inches. So visualize the distribution we're talking about. All right. So the mean is 68.6 inches. So mu is 68.6. So the center of the normal distribution is where the mean goes. And we have a standard deviation of 2.8 inches. So that's sigma equals 2.8. All right. So our x value is the 72 inches. The percentage of men who are taller than a showerhead at 72 inches would be men, heights greater than 72. So here's 72. And then this area here divided by the total area will be the percentage of men who are taller than the showerhead. So really just this area here because the total area is 1. So if the question had asked find the percentage of men who were shorter than a showerhead at 72 inches, it would be the area to the left of 72. So percentage of men taller than 72 is equal to this area. All right, so we don't have, when we don't have a technology that will just take a new mean and a new standard deviation, what we would have to do is use our formula. So z is equal to x minus mu over sigma. So that means the z-score is 72 minus 68.6 over 2.8. So 72 minus 68.6 and divide by 2.8. So a z-score of 1.2143. We'll call it 0.2143. So then you translate this over to a normal distribution where mu is 0, standard deviation is 1, and then your z-score will be 1.2143. So then you'll be looking for this area, and the red area is equal to 1 minus the green area, because most tables or technology devices will give you this area to the left of a given score. With our normal distribution calculator, the way we get that, we go to Stats, Calculators, Normal, and okay, the default mean is 0, standard deviation is 1. So we plug in our 1.2143, 1.2143, and then compute. So we get the area to the left of our z-score is 0.887. We'll round that up. 0.887. So we have 1 minus 0.8877. All right. So that will be the same area. This is the same here as it is here for both distributions. Different scores, but the same area when you use the translation. Now we can come back to our 68.6 for our mean and 2.8 for our standard deviation. So 68.6 and 2.8. And then 72 was our x score. And compute. And notice it gives us the same area to the left of the x score. So 1 minus that number would be the 0.1123. And we can also get it by typing in using the between function of the calculator. Put in your x score and then put in some arbitrarily large score to the right to get the area from the smaller number all the way towards the end of the distribution where it gets so small that it's basically no more area after numbers that big. And we get 0.1123 like so. All right. So 11.23% of men are taller than a shower head.